Okay, good morning. I am Milind Sohoni. I am also the head of CTARA, a center devoted to technology and development. So Professor Rangan talked about research and various options, various tools that by which you do research, and Professor Amarnath, indicated what are the mechanisms which are there in IIT to, one of the mechanisms to pursue research. So I am going to talk about what really should motivate research, or how would you, Professor Rangan Banerjee also talked about interdisciplinarity and how it is, how it comes about naturally. So I'm going to dwell more on that. So here is my talk. So actually I gave this talk, can you hear me well? Okay. I gave this talk last week to about 8,000 teachers, who must have taught you in your engineering colleges. So this talk is about the role of a teaching and research paradigm for national development. So I'm going to argue that actually national development poses very interesting problems which can actually benefit you and your profession and your own development. So next, so please raise your hand if you have any question, or maybe we can take questions at the end of the talk. Okay, so this is a longish talk, so you have to pay attention. Next. So first of all, I'm going to talk about what is science and what is engineering, and what is the role, how are they different. Then the second thing is, the objective is what is society and development, and how do science and engineering interact with society and development, and how are R&D problems posed, how do they come about, and then I will take up a case study, the drinking water case study, and then finally I will say, I will sum up all of these things and point to what are the outcomes and how have we, how would students and the institute and society benefit. So let's understand what science is. Science, of course, is about observing phenomena and explaining them, right? So we have lots of data, and then we plot the data, and then we, make some conjecture about what the, make some conjecture about what an explanation should be, and then we test our hypothesis. So for example, so if you see, so the first thing obviously is observation and documentation, right? So first you must observe something. Say you want to observe sunrise and sunsets and see how they change with time of the year. Then first of all you must have a nice watch, and which can make accurate observations and plot it. So this is the first part, observation and documentation. The second part is obviously you have to formulate a law. You want to predict what's going to happen next day or next year at the same date, right? So constructing a relationship between the variables, and finally you have to test your hypothesis, right? You have to test whether you made the right, you made the right relationship. So the above steps are repeated till you have succeeded, right? Till you have obtained. So here's an example. So here is a bore well, and I observed the bore well over over the last 30 years on many days. So each plus here is an observation. So for example, this is November, right? November 15th, say some year I saw this as my reading. Is that clear? So if you see this, then these are various observations, and then I make a law that the water in the bore well decreases linearly with time. Is that okay? So this is my law, and then I see that, well, it reasonably explains the behavior of the well. Correct? Are you following me? Okay. So if you see this, well, you'll see what about these errors? Well, there are some errors. There are observational errors. There may be friction. There may be, maybe a monsoon was good, maybe monsoon was bad, and so on. So by the way, these examples not only work in the physical sciences, but they also work in the social sciences. So for example, here is each observation here is of a village in one particular taluka, the Shahpur taluka, okay, in Thane district. So Thane is, our neighborhood district is Thane. So each village is one observation. What have I plotted? On the x-axis, I have plotted the literacy fraction, the fraction of people who are literate. On the y-axis, I have plotted the fraction of people who are under 6 years of age. Okay? Is that clear? So now what do you, if the fraction is greater than 6, of fraction of people, fraction of children is greater, then what do you expect the village population to? What is the meaning of a larger fraction, larger number of children in the village? That the population is growing. right? If it's steady state, then the population fraction of children would be say about 16% or 10%, correct? If it is more, then you expect that the population is likely to grow. Is that clear? Right. So what does this show? That as the education, as the literacy increases, the fraction of children actually starts reducing, right? So if you want to control population, then a better way or one way of doing it would be to improve literacy, right? So you see that here is where science has already started coming in, right? So we have all these plots, and then we draw the best fit line, least square line. So I just drawn the least square fit line, and I see that this is a reasonable law, that if you increase literacy, for every percentage change in literacy, the percentage drop in the population under 6 is so much. This is a very reasonable law. Is that clear? So this I call as science. Next. Oh, here. So now what is engineering? Well, engineering is about, where do you want to be? Engineering is about change. Okay, science is about describing reality, while engineering is about changing reality. So you're not happy with your current state and you want to change it, correct? What does science do? It just tries to describe what reality looks like. Is that clear? So supposing we want our villages to be here, right? So how do I go from here to here, right? So is that clear? So you see, these are some of the questions. For example, what should I do so that my villages are 90% literate? Or, for example, what should I do so that my public transport is better? Correct? So when you have engineering, there's always a value which society has put to a desirable change. Right now, for example, you saw that there was some helicopter which was, that 3 Idiot helicopter is going up. So the question is, why has we made it? Right? When you say that it's going to fetch money, but you have to spot that there is a need or some value which society has attached to it, and that's why it is going to be useful. Right? So engineering always has something which society values. Is that clear? Okay. So next. So really, what is the engineering cycle? First of all, identify a societal problem and a stakeholder. Okay, by the way, I know that when we come to the next slide. So let's, just pay attention here, because I'm going to cover the case that you are in soon enough. Right, so identify a societal problem and a stakeholder, right? So who are you doing it for? The next step is analyze the problem and separate it into elementary subproblems. You see, for example, if your problem was to improve the public transport in this city or in your town, correct? Then it has many subproblems. It maybe make the driver and conductor more courteous, maybe design better routes, maybe save money by operating different frequencies of different buses at different times, maybe improve the roads, that may improve the condition of the buses. So many aspects. So whenever you are faced with a situation, say improve the quality of public transport, the problem partitions into many subproblems, correct? And you have to tackle each one of them independently, devise the solution, then synthesize the solution back and give it to the stakeholder. Is that clear? So, so engineering really, if you want to change society, then you must pick up problems from society, divide them up into subparts, find the solution, go, take it back. So you see that, delivering change is the key engineering function, right? So don't forget that, your professors or your deans or your directors may tell you anything, but delivering change is your key function. You have to deliver change, fine? And what are the key processes? Modeling and design are the key processes. So you must see a situation and model it as an engineering problem, right? And then design for solving those problems. So modeling is so let's just go to the next slide. So here is a complicated picture, okay? But it tells you what exactly is the true engineer. So here is society, then identifying a problem, analyzing it, and putting it into various slots. Civil, where there's some civil engineering, there's some psychology, maybe there's some maths and OR, maybe there's some IT, and then forming the solutions, synthesizing it, and then giving it back to society, right? So this is the true engineer. The true engineer is actually like this. So what does the true engineer need? He or she needs societal skills, some creative skills, and domain knowledge, right? And this is how interdisciplinarity actually comes in, correct? So next, so immediately you see that the true engineer is actually interdisciplinary, right? That you've seen, I mean, if you just pick a simple problem like making public transport better, you see immediately there are so many issues to handle, correct? So note that all research really takes place over here somewhere, right? Research, you may be doing civil engineering research, you may be doing research in IT and so on. But that research, if it is to be meaningful, it has to go back to society, which means that you need to have these skills as well. Is that clear? So unless you have society modeling skills and analysis, and these, creative skills, you will not be a good engineer, right? So let us see, why are you here? Well, most of you are here to get a job, right? Most of you, how many of you are here not to get a job? Very few, right? Most of you are here to get a job. So let us see what is the method of engineering which leads to jobs. So one other model is the company. So what does company do? Company interacts with society. So company decides, well, now we need a new brand of tea, or we need a new soap or a new shampoo, correct, or a new car. So it is the company which decides what are societal needs that it wants to target, correct? And then it has various departments: finance, manufacturing, design, HR, sales and marketing, and so on. And each of these departments are housed, they house employees, right? So this is where you want to be, right? You want to be an employee, right? So is that clear? So whenever there is a need, maybe sales and marketing spot a need, then they go to finance, ask for money, and then they maybe do the manufacturing and design. Then there's some HR who hires and fires, and then it comes out and then profits are made, correct? Right? So one immediate consequence of this company model is that it may be very efficient, but the employee need not be any interdisciplinary at all. The employee should do one job well, correct? And that is why all of you are here. Tell me one job to do well, I don't want to be bothered. I want to make money, good salary, yeah, so that's the thing. So the employee need not be, so it desires much lesser skills from the employee, right? Okay. The problems, so second consequence of this is that the problems which are taken, for solution by company, which problems are going to be addressed? Which give profit, correct? Companies are going to pick up problems which give them the most profit. And what are the companies, what are the areas where most profit can be made? Well, it used to be IT till last year, it is going to be pharma next year, telecom and automobile engineering and so on, right? These are the areas which make the most profit, right? So therefore there are a lot of companies in this sector. But what are our problems? Well, our problems include IT and so on, but they are also drinking water, solid waste, you walk around, you come through main gate, you see it's a problem, right? But are there companies addressing those needs? No, because IT pharma is going to pay better, correct? Any questions? Okay. So then, obvious question is that if these are needs, drinking water and solid waste, then why is it that our young engineers like you people are not starting companies in this development sectors? Why is it? There's an obvious question, right? Correct? If there is a perceived need and if market economics works, then whenever there is a perceived need, people will rush in to exploit the opportunity. So why is it that this is not happening? So any guesses? Anybody wants to suggest something? Yeah? So? Correct. So then, so there is another model, right? The entrepreneur, right? That is what, Professor Amarnath was talking. What does the entrepreneur do? So, it says that, well, you don't need all of these knowledge, you can have employees. But the entrepreneur does the social modeling and the analysis and synthesis. right? So the entrepreneur actually does the job and he offloads his technical work to these employees. This is how a company starts, correct? That's how a company starts. So then, is that clear? So the engineering cycle, this part is what is very crucial, right? And this part is what the employees really come from. Is that clear? So the next thing is, so entrepreneurs obviously have a low cost of entry, and then development problems, hopefully these entrepreneurs will take up. So then the question is, why are there no entrepreneurs in drinking water? And the reason is that our engineering colleges do not teach entrepreneurship at all. Our engineering colleges teach civil engineering, teach whatever, psychology, sociology, mathematics and IT and so on. So if you look at our curriculum, 80% of the curriculum is completely technical, or 100%, right? They do not teach you how to interpret society, what are their problems, how to decompose a problem, how to study what the problem looks like, and alienate. They don't teach, and that is the result that since we don't teach it, none of our engineers really have this skill. Okay, and that is why there are. Do you know that? How many of you know that we are staring probably at the worst possible drought in the last 50 years? Do you know that? Many parts of India are actually going to go without water, drinking water, within 4 or 5 months. Do you know that? But are there any, do you have any, how many of you have seen a well? All of you have seen a well. How many of you have seen a well through your engineering college? 1. So right, 3. So only 3 students out of whatever 300 have been taken by their engineering college to a well, while 80% of our people drink groundwater. Isn't this a shock? That so many people, so now for example, now there will be drought relief and so on, fund and so on, and new wells have to be dug, new pipe water supply systems have to be made. Do we have the expertise? No. So that's why our people are going to die, right? Because you see, after all, a Java applet is not going to bring water, correct? Wells are going to bring water, right? We are pretty good at writing Java applets. We are not pretty good at building wells. That is the terrible state of our engineering education. Okay, so you see that since we have ignored how to teach entrepreneurship, what is society, what is the relationship of engineers with society, we are now doomed to be employees and wait for a company to work in drinking water, as basic as drinking water. So let a French company will come, it will start drinking water, then we will become employees, right? Okay, no answer. Am I right or am I fairly right? We are waiting for the right company. Huh? Okay. So now a key observation. By the way, I have written an article in Current Science, which is a fairly prestigious journal of the Indian Academy of Sciences. If you look at the June issue of 2012, I have written an article. You can see it. It explains how how R&D, how our engineering R&D is, and why is it not going to benefit our society at all. Yeah. So what does it? Basic thesis is there is a huge development deficit, okay, which needs attention, right? And that development deficit is going to be exposed when a drought comes. You see, what is a developed society? When there is it provides for water, it provides for food. That's number one. How does it do it? So first of all, one hallmark of a developed society is that it knows how to. You see, when good things happen, you know how to pay for it. You want a tomato, 2 rupees a tomato, right? So for good things, knowing what to pay for good things which happen is easy. But paying for bad things to not happen is what is development. Right? Paying for surety, understanding risk, being prepared for it is that clear? understanding how to pay for bad things which don't happen. So for example, now there is a drought. What is a bad thing which is likely to happen? That a lot of our people are not going to get water, right? Now we don't want that to happen, correct? But can we pay for it? Do we have mechanisms to pay for it? That is the question. Okay, right? So, so current set of companies may not have sufficient incentives to address these problems, right? These companies also do not have the need for 5 lakh engineering aspirants every year. 2 or 4% are here, 2 or 4% of you are here. But what was the 96%? They're all waiting for the great IT job to come about, right? How many wanted IT jobs in your colleges? You are from various colleges. Is this not true? Largely true. That you are waiting for biotech or IT, some company will come and give me a job. Is this very wrong? Am I incorrect? Largely correct. Like placement is a big problem, right? Placement is a big problem. Right. So, so these companies do not have the need for IT companies cannot take in 5 lakh engineers who are graduating every year. So our current training of engineers is not just going to work, right? Not going to work. So there is actually a supply demand mismatch. Development sector needs engineers, but engineers are not trained to do that. IT and pharma and wants only 1 lakh engineers, but there are 5 lakh people clamoring for IT pharma jobs or high tech jobs, whatever. Correct? So what's going to happen? So we are misallocating funds and engineers, right? Okay. So is there a problem? Is there a solution to this problem? Correct? So solution is that, so this is, by the way, this is where, where actually, you will forgive me that this talk was actually for engineering college teachers. It was for engineering college teachers, right? So, so well, there are some, basically what it says is that IIT or your engineering college is an important, knowledge generator at the taluka or district level. That each, like IIT, has to be responsible for main gate, at least. No? If IIT is such a great institute, then at least main gate should be better. Traffic outside Bombay city should be better. Or no? We ultimately, an engineering college should be responsible for the technical problems in its area. That's a very simple claim, and that is all I am making. And in fact, you will see that in the developed world, that is indeed so. Right? The local university, like you go to Harvard or MIT, they talk about the whole world. They think, they write books about Mongolia, they think they are masters of the world. While if you go to University of Michigan, it says Michigan is my world. Everything happens in Michigan. There's a drought, there's a fire, there's a risk of forest fire, there's whatever. I got to know and I got to advise. Right? So they spend their big, and that's how they become big, because they develop the tools to solve real life problems. Is that clear? University of Minnesota, all the GIS that geographical information systems came out of University of Minnesota. Minnesota is a really small state. Okay, you are 1 or 2%, right? You are 2% of the applicants. Minnesota admits 1 out of every 2 people who apply. Okay? So you would say it is third rate university. No. In fact, it did real life, what it did was, it picked up real life problems. And the whole GIS infrastructure in the industry has come from Minnesota. Is that clear? Okay. Yeah. So, but I will say that, there are, so I'm going to just give you an example how to pick a real life problem and how to benefit from tackling real life problems, be whatever your area. Okay? So, so I am claiming that there are sufficient incentives to work on a real life problem, because you have a customer in mind, you have to deliver. So that will make you look for tools, make you design stuff, let's try this, let's try that, and so on. Is that clear? So let's see. So of course we know what rural drinking water. What's the time? How much time do I have? 5 minutes. 5 minutes, no? 10 minutes. Okay. So yeah, so then let's look at, we of course know that much of rural India actually uses groundwater, 80%, 85 maybe. And this comes from various sources. And then, let's understand. So let's now, for example, there's a drought coming. We know there's a drought coming, right? So when can I call a village safe? Well, Government of India says when it gets 40 liters per person per day. Every person should get 40 liters, then it's called safe. By the way, urban norm is 150. So people in cities, they need 150. People in villages need only 40. They may keep, they may keep cattle and they may keep goat and they may have to, do gobar to their house every day in the morning. That needs water, but still they have to do within 40 liters. Okay, so be it. So government has said, well, this is the situation in many of the districts in many wells. This is the situation. Have you seen a dry well? How many people have seen a dry well? My God. So many people have seen a dry well? Really? Where did you see? Yeah, blue shirt. Huh? In Ullas? Where? Ullas? Last year. But where is your village? Haryana. You've seen a dry well, right? Anybody else seen a dry well? Yeah. Huh? 11 years. Recently. Dry well. Dombivli. Baapre. So you see, but by the way, so all dry wells look very similar. They also, if you've seen one, you've seen them all. Okay, there's nothing great about a dry well. You just peer down, it's a dark hole, and there's just stones at the bottom. Okay, and maybe there are plastic bottles. Right? That's how a dry well looks. Okay. So what happens after that? When the wells go dry, the women go, tough go. When the going gets tough, the tough get going. Right? So women are obviously the toughest, animals on earth. Right? So they trek long distances and fetch water like this. Right? When that happens, by the way, 1/3 of the women's energy actually goes in fetching water. Another 1/3 goes in domestic duties, and the remaining 1/3 goes in, that's domestic duties. Remaining 1/3 goes in what? What do women do? Cooking. What do women do? Fetching firewood. That is, the bane of 1/3 of the time, of 60 to 70% of the women goes in fetching fuel for cooking. So these people want, energy, water and so on. Basically they want engineering services. They want sadak, bijli, pani is what? They are engineering services. People are looking for engineering services. Okay? Yeah. So anyway, this talk is, I'm not going to, it may not get time, but here is how we start analyzing. So I know that last year Thane district had a very bad time. So there were, this is the description of Thane district. Well, there are population 81 lakhs, 23 lakhs rural. It is like taluka, there are 5 tribal talukas, okay, and then so on and so forth. So of course there are very few engineers, okay, most engineers are doing IT. Okay, so in Thane district there are very few. There are only about one engineer for every 20,000 people, only one engineer, okay. So then here is where so this is Thane, and these are the villages which are all tanker fed. You know what is tanker fed? Which need tanker for drinking water, correct? So they very, very poor supply. They cannot bathe every day, and they go to shit, go elsewhere and shit, God knows what, right? So these are the tanker fed villages, okay? And if you see what the what the scheduled tribe population is in what's it is Jawhar, Mokhada, Murbad, 24% of taluka is tribal, but in tanker fed villages it is 74%. What does it tell you? That tribals have a tendency to go without water, no? No? Tribals seem to have a tendency to go without water and call for tankers, right? Correct? Then you look here, then you see something else. Well, anyway, this whole slide is there, you can. So by the way, so then let's look at where are the large drinking water schemes. Well, you see that they are all over here, the red ones, closer to the urban areas. So the rural drinking water schemes, they are called RR in Maharashtra parlance, RR, rural regional schemes. They are all actually serving peri-urban areas. So, in Marathi, they say, Aag Rameshwari, Bamba Someshwari, So the fire is in Rameshwar, but the fire engine is in Someshwar. Right? All the rural engine, these are the schemes. Right? So you see that, well, next. So anyway, these are some technical, so we divide up the problem. We follow the same. Let's see what is the technical problem, the social problem, there is some permission, then the legal problem, civil engineering problem, simulations and so on, right? So many issues. So what we did was, we did a feasibility study. We said that, let us see if we can build, there is a big reservoir here, which is supplying water to industries and so on. Let us pick only 5% of that water, because drinking needs are very small, and see if we can build a rural regional scheme for that, that belt. Correct? So what does it involve? Well, by the way, I am not a civil engineer, nor am I a sociologist or whatever. I am basically an applied mathematician, or actually I am in the computer science department officially, and also head of CTARA. Okay. So what is a drinking water scheme? Well, there is a water source, then you pump it up, and then there is the main tank, and there are sub tanks, and there are these clusters of villages and so on. And that's how it goes. Correct? Okay. So, these are the basic steps. I won't go through, you should study them. How did I partition the problem? So this is what I mean by an ideal engineer who can partition, understand what the problem is, then partition. So you see, by the way, if there is a visiting student that CTARA is from Berkeley, California, and you will see how his skills are. They are very different from ours. They know how to understand, they can model society, they can design for society, and they have that interdisciplinarity. Is that clear? Okay, so what are the steps? This is exactly what he would have done. Assess need, severity, extent of problem, meet with all stakeholders, go to villages, have a questionnaire, take meeting and so on, right? Then locate source, judge, talk to the administrators, talk to the people, talk to the administration, do an optimization, and then document and report. Is this very difficult? Well, if you're doing it for the first time, it is, right? So, this is what we did. So, we went, talked to the people, then met with some NGOs, talked to the engineers, and so on. And then this is our target area, then this is our source, and these are the 70 villages, habitation, all of these, to be served. So, for each village, you got to know its population, you got to know its growth rate, so that 30 earth hence, what is going to be the demand, 40 LPCD, you know the demand, lat, long, elevation of each point, and the demand. So, now you are ready for a mathematical problem. If you know the lat, long elevation, latitude, longitude elevation, and the demand projected over the next 30 years, then now optimization can come in. Right? Now it's a mathematical problem, right? To make it into a scheme. And this is the scheme. So it has 17 clusters. Each of these is sub tanks, right? And then anyway we designed the whole thing. Then used simulations, used GIS, used whatever, and came up with this answer. 40 LPCD needs so much investment, and that's well within government norms. Okay, that is well within government norms. So with this report, feasibility study, we gave it to the government, saying, look, it is possible, and we gave it to the people. So now what happens? Whenever the MLA goes to that area, people say, "Arey, wo IIT ne report diya hai that it is possible 2000 rupees mein ho sakta hai. Why are you not doing it?" Isn't that clear? If somebody gives you a report, feasibility says that your problem has a solution and it is fitting government norms, then you are likely to demand, why is it not being done? But that knowledge is very, very important, and that is where IIT should come in. Is that clear? Right? Anyway, so obviously, what are the benefits? Well, Karzat may, where it was done, it will benefit. But have we benefited through this process? If I do this, if you as engineer does it, Will it benefit you? No. Or does it benefit you? Involving in this exercise, will it benefit you? Now, if you want a job in Hewlett Packard or whatever, whatever you've come here with getting a job, right? Do you think doing this activity has helped your job prospects or destroyed them? Doing this, interdisciplinary skills and so on, do you think it has helped or not? Yeah, because you will not be given a techie job or nerdy job. You will be taken to the higher job. You will meet the customer, you will face the customer, you will go, yeah, why don't you go to this customer client, meet and find out what the demand is. Exactly model the solution. So in fact, learning such skills actually will help you whatever job you want later on, or not. Is that correct? Okay, so let me, so anyway, so this is my vision, our vision, and let me stop here. Thank you. So any questions? Yeah.
So you said that in our engineering colleges they don't teach entrepreneurship.
Not entrepreneurship, modeling, so society, talking to society. They don't teach talking to society. And they don't teach the creative part of engineering, which is into how to separate the. By the way, let me stress that entrepreneurship is another model. There is also state service model, right? Silicon Valley is only one part of America. 90% of America is actually served by very good State Department engineers. Okay, not all of them are entrepreneurs running here and so on. Okay, so entrepreneur is just one model. Basically, it's a model of interpreting society and designing for society. Okay, yeah. Any other question? Yeah. And the companies. Yeah. Money involved, right? Yeah, so, right, so, but what I am saying is that, you see, if there is a problem, then people should rush to solve it because there is money involved. There are, government of Maharashtra willing to pay, right? So, it should, but then it needs skills which we don't have, namely skills of interpreting, going out, talking to people. How many of you have been to, know what a Gram Panchayat is? Good. Who heads the Gram, who is the political head of the Gram Panchayat? Sarpanch. What is it? Have you seen a Tahsildar? What does he look like? He's not one with big mushes with a big lathi. He's not like that. He's actually an ordinary person like you and me. In movies you see him with big lathi and hammering out people. He's not like that at all. He's like a mousy, like he's so scared and so on. So we have to understand that these are skills which are easy to learn and we have to go out. Does it make sense? Any other question? So by the way, you should read that current science article. It's there on my web page. Huh? Huh? They have questions? Yeah, okay, please. Other hall. So other halls, I don't know where to point. Yeah, other halls. Are there any questions? Well, they can't, probably they're gone to sleep, so that's okay. Okay, so thank you. But I suggest that, the deeper questions, why are we like that? Why are we like this or like that or whatever? Those I have one explanation. You can look at my current science article, fine. But besides all of this, what I'm saying that I don't hope to, that all of you should, you go ahead with your jobs and be employees, good employees and so on, okay. But remember that there is an opportunity, to jump ship, okay, and that this spark that there are some skill which I could learn and, maybe things can get better for me, right. So I'm in fact inviting the young entrepreneurs, or the young company, or the young state workers, or the young whatever, thinkers, or the young whatever, right? That there is a vast section of problems which are waiting for us to solve. Okay? So let me stop here. Thank you.